Let's do our first implicit differentiation problem. It's going to turn out pretty easy. I hope it's all going to be linear, but better start out easy than too hard, right? So suppose you're buying coffee for a meeting and you don't know how many people will be there or what type of coffee they like. There's two types of coffee available, which we'll call A and B. It's pretty expensive coffee. Maybe you work at Google or something. We'll say how many cups of type A coffee will we buy? How many cups of type B? So what formula involving X and Y describes how X and Y have to relate to each other? Let's suppose I'm going to use all $45 of what I've been allocated. So pause the video and write down a formula involving X and Y. All right, welcome back. So you could say it's like $3 for a cup of type A times X cups of type A plus $5 for cups of type B times Y cups of type B, and altogether that has to equal $45. I'm writing dollars here after the way we would write kilograms or miles or seconds or whatever. So do you agree the units all work out here? Cups of type A cancel cups of type A, give me total dollars. Cups of type B cancel cups of type B, give me total dollars. Dollars plus dollars equals dollars. So that's the formula we're dealing with. And once we've made sure that the units work, we can then just simplify 3 times X plus 5 times Y equals 45. I don't mean algebraically simplify, but just not write the units anymore. And then what graph do these follow? Take a sec to sketch a graph. Obviously we'd put X here and Y there. So you'd say, well, with my $45, I could buy 15 cups of type A coffee, because 15 times 3 is 45, but then I would have $0 available for type B coffee. Or for the $5 coffee, I could buy 9 of those and then I'd have $0 left over to buy X type coffee or A type coffee. And then because this is a linear equation, I could say anything on the line between those. We're not going to worry about fractional cups of coffee because it's all a silly example anyway, right? So this is the formula that X and Y have to satisfy, and I know I could solve this for Y in terms of X, but we just wanted a simple formula. The question we're going to ask is, for every one more cup of type X coffee that I buy, how much does my type Y coffee purchase change? So let's write that down. For every new cup of type A that I buy, how much does my type B purchase change, assuming I'm still using all 45 of my dollars? Can you write the answer to this question in math notation? It would be, how much does Y change per unit change in X, or just dy dx, or just the derivative? Now you can probably compute the derivative of that line without too much trouble. Just compute the slope and that's your derivative, right? But we're going to do it by implicit differentiation. So we're going to take this formula, 3x plus 5y equals 45, and differentiate both sides with respect to x, because we want to have dx in the bottom, because if two things are equal, then their derivatives should be equal, right? If two graphs are exactly the same as they go along, then their derivatives should be exactly the same. So we say differentiate both sides with respect to x. So we could just write d dx 3x plus 5y equals d over dx 45. And then let's actually apply this derivative. What is the derivative of 3x? well, I guess we could show ourselves just kind of distributing it. d dx 3x plus d dx 5y. And then what's d dx of 45? Well, 45 is a constant, so its derivative is 0. And then what's the derivative of 3x? It's 3 times d dx of x, so that's 1. What's the derivative of 5y with respect to x rather than with respect to y? You're still going to have a 5, but then you're going to have a d dx of y, or you could say dy over dx. And that's still going to be 0. Well, look at that. We wanted to know what is dy over dx, and now we have a formula that involves dy over dx. It's like magic. So now just use basic algebra to solve for dy over dx. What would you do there? Maybe subtract 3 from both sides. And you'd end up with 5 dy over dx equals minus 3. Divide both sides by 5. And then you'd get dy over dx equals negative 3/5. And that's our answer. Does that make sense based on our graph? If you go back and compute the slope, does negative 3/5 sound plausible? Or you could have solved this and you get negative 3/5. So we're going to be using implicit differentiation to do that same basic process, but on things that are more complicated than linear in the next video.